So this is good old chapter 2 stuff. What I'm going to be doing is I'm going to be working off of that page 127 there. Kind of back and forth on questions of that for examples, and then give you guys some stuff to do. So to start out with, we're going to talk about what's called domain and range. For lack of better terminology for that, your domain values are just your x coordinates, all your x values. And your range are your y values. And the really, really easy way to remember that is what comes first in the alphabet, domain or range.
Domain.
And what letter comes first in the alphabet, x or y? That's all it is, guys. These are your x values, and these are your y values. What happens is, as we get into this a little bit more specifically, we're going to start talking about for every x there exists one y value. That's to tell whether or not something is a function. That's where that comes from. So a function for every x value, there is only one y value. Basically what this means is the x values can't repeat. Your x values can't repeat. That's how you determine whether or not something is a function. You probably saw that in an algebra class when you did what's called the vertical line test. You remember that?
Oh yeah.
When you have anything that you graph, let me slide this up a little bit here. Anything you graph, if you're graphing a line, does this line pass the vertical line test? Which means for everywhere that line touches the graph, is it only touching it in exactly one spot? Yeah. So this would technically be a function. Yes. A parabola. Oops. Does that pass the vertical line test?
Yes.
Yeah. A circle.
No.
No, it doesn't pass. So that's not a function. Not a puma. Not a function. Okay. Eventually we're gonna have parabolas. Did you know that parabolas can go left and right?
Yeah.
We're going to do that with parabolas. These will not be functions. Okay? So this is a no. So like I said, basically we're talking about domain and ranges. That allows you to determine whether or not you have a function. And that's what we use it for. If you ever list domain and ranges, I don't think never mind. I don't think we do that all that often, to be honest with you. Function notation. This is a huge thing. You see it a ton on standardized tests. Function notation, when you see stuff like this, is nothing more than direct substitution. What they're doing here is that they're giving you two separate equations. They're giving you f of x is 2x minus 5, and g of x is the absolute value of 3x minus 1. They're telling you that you have two functions because they write it in function notation. So we know that, well, let me ask you this. Do you know what the graph of absolute value looks like if you graphed it? They look like V's. Okay, they look like V's. All right, up or down. That's how they all look, and they just move them all over the place. So what this is saying, hey, look at the f equation, and everywhere I see an x, what am I going to put? 3. Put a 3. So it's saying, hey, dummy, use the f equation. All right, f equation is 2x minus 5. Hey, dummy, it's not really saying that. You just put, that's all you're doing. And what's your answer? Correct. Very good. Okay, that's it. You see this a ton. There's actually problems on the ACT that look like this. And then, what is triangle triangle of 3. It's something like that. It's like function notation. It basically says, take the value, take the triangle equation, put 3 in it, get that answer, and put that in again to the triangle equation. So you're just doing it twice. Instead of writing f of x, they're saying triangle of x. It's kind of weird how it does it, but you'll see it when you go through it. So. It's function notation, function style problems like that are a very simple, quick thing that they put on ACTs, SATs. You see it all the time. Okay? It's a very, very common thing. So that's why I just wanted to show you, see if you remember. Too many tabs. What else we have here? How do you find slope?
Rise over run.
So we have slope, rise over run, okay? What is the formula, do you remember? That's slope intercept form.
Oh,
You guys remember how to find slope? What is it?
y minus y over x to
Yeah. It's the change in y's over the change in x. You guys have all seen change written out as delta before, right? As a little triangle. Greek alphabet, they're all weird like that. They use these different symbols for everything. So speaking of which, do you know why they use the letter M for slope? Think about the alphabet here. Well, what do you see A, B, and C being used for in math all the time?
Variables.
Well, more specifically,
Signs.
no. Yeah, you're on your way with that Pythagorean theorem. A squared, B squared, C squared.
Okay.
What do they use D for? Distance formula. What do they use E for? There's a button on your cup there, E. It's exponential form. F function, G function, H function. They use it all, or heights. You see that a lot. I. Do you know what that stands for?
Imaginary.
It's imaginary. We talk about imaginary numbers here pretty soon.
Square root of negative.
Very good. Square root of -1. Imaginary numbers are awesome. They're numbers you can think about, but you just don't talk about. It's in your imagination. I'm graphing an imaginary number right now.
How do you test on it?
You think about it. You think really hard about it. J, they use J for something called joint variation. We get into that, I think, with polynomial stuff. K they use a lot for constant and variable. L, length. Then what are you left with? They went down the alphabet and they landed on M. Correct. S was taken because they used that for sides. I just made all that up. You guys know that, right?
What did you make up?
All of that. What's slope intercept form?
Why those are supposed to be?
Why do we use this?
Set up graph.
Graph. It's the easiest way to graph an equation of a line. Plus, there's a button on your calculator that says y equals. Where your slope is your m, your b is your y-intercept. Point slope, what does that look like? Oops.
It's point out like the middle, like where it's 0, and then it's like it's 0. Oh no, I don't know.
Not quite. What was point slope, remember? You're close. You're very close.
Parentheses and it's like in
Yeah.
on the right side of it.
Point slope. Point slope form. I think point slope form is a very workable equation. Point slope form is that y minus y sub 1 is your slope times the quantity x minus x sub 1. The reason why we use point slope form is because when you have a point and its slope, convenient they called it point slope form. Because then that way, from a point slope form of equation, you can easily send it into slope intercept form, just by some direct from solving for y. We use point slope form all the time for when we write equations that are parallel or perpendicular through points. You guys remember doing that vaguely last year in geometry? I don't know how much Seb did that with you guys. I know that in regular geometry classes we spent a good chunk of time on it.
On
Writing equations lines that are parallel, writing equation lines that are perpendicular.
Oh, yeah.
Okay.
We did that.
When we do this stuff, and there are some problems with that in this section here. The way that I set it up is I do it in such a way that it forces you to slow down and actually do all the work. Let me show you an example real quick. Very slow. So this was, so we'll say it's parallel to y equals 5x minus 1 through, what was it, 3, 5. So a lot of times when I do these types of problems, you're setting up the parallel equation or it's a perpendicular problem. No matter what, you're doing the same thing. First thing you do is, what's your original slope? What's the original slope in that equation? 5. Good. Is it a parallel slope or is it a perpendicular problem? It's a parallel problem, so I don't do this. So what's parallel to a slope of 5? 5. Good. What would be perpendicular to a slope of 5? Negative 1/5. Very good. Remember, when you're doing perpendicular, you change the sign, flip the fraction. Okay. And now all I do is write out point slope form. And I solve for y. I use point slope for this stuff all the time. I think it's really, really easy to substitute in and out of.
Where did you get the first 5 from?
I took it from the point.
Okay.
I got it from the point, the given point that we had. So substituting through, we get what? 5x minus 15. Add a 5 to a negative 15, what do you get? That should work out just fine. And here's what's cool. I think I told you guys that a lot of times with the graphing calculator, you should be able to check answers real quick. What's nice with this is that if you go to your calculator quick and we put in our y equals table, put in the equation 5x minus 10. I want to show you how you use the table. Should get new pictures of those two. Yeah, thank you. Takes forever for the silly thing to load. One of the things that you can do with the graphing calculators is that you can always go to your table function to see if the ordered pair that you're given actually is on that line. So I think that we came up with the equation 5x minus 10. Throw that in your y equals table, and then, or excuse me, throw that in the y equals part, but then go to your table. In order to get to your table, you hit second graph. Eventually I'll get there. But if you hit second graph, scroll through and look for the ordered pair. What would we start with? 3, 5. Hopefully when x is 3, y is 5. If it isn't, we've probably done goofed.
So when we have it, we just
Yep. It's a nice quick way to check a lot of stuff. There's a lot of things, or even if you think about when you're doing that function notation stuff, if you're just plugging and chugging, because there are a lot of times you do, if you put the function in your y equals, just look through the table values for x, you'll never get it wrong. The calculator did all the work for you. So, still not loading. Screw it. I'm not bothering with it then. I love my computer. Let's see here. What else I want to use? Graphing inequalities. Yeah. Do you remember how to graph shade inequalities?
Yeah.
Okay. You know what? I'll probably wait to do that because I want to bring that in with the other stuff. Let's do this then. What I'd like you guys to do. Oh, there's also standard form. Forgot about that one. Standard form. You guys remember what standard form was? Yeah, you don't use it a whole bunch. It was the, what is it, ax plus by. Is that it? Is that right? Isn't that it? AX plus BY equals C? That's standard form, right? You don't use it very often. Yeah, I wouldn't even, you know what, I wouldn't even bother with standard form. A lot of times we're going to, because standard form comes in, we'll use it more when we talk about quadratics, because there's some easy stuff we can get out of that. What time is this one over?
24.
24? Okay. Let's do this. Since the second part of chapter 2 is basically going to be a lot of the graphing stuff, and I was hoping that I was going to be able to use that Excel program, which didn't load, so I don't have enough graph paper for you guys today, so I'm going to have to hold off on that one. So let's do the homework problems that are on here. Let's get up through the graphing portion of it, because then tomorrow we can work on graphs, and then we can start working on shading, how we do inequalities with shading, because as we get into our linear stuff, we're going to start doing some of the how you shade boundaries and things like that. Yeah, dude. It's like our youngest got R2D2 sketchers. Have you seen those? So not only do they look like R2D2 on his feet, but not only do they light up, they also make the noise. So I'm sure his preschool teacher loves them. Great. He goes, he does all that. Oh, I was right. Sometimes I forget things because I get old. Yeah, Google, you're our best friend. So let's do this. So this is on what, 127? So let's start with, we'll do evens, but I don't want you to graph. Let's go evens up to 20. I gotta talk about this constant variation because we don't have time to do that right now. I'll do that tomorrow. Yeah, let's just go evens up to 20, and then we'll worry about the rest of the equation stuff tomorrow. Yeah, that's fine. Yeah, that's fine. You got it already. It's just, no, that's right. 127. Yeah, let's go evens through 20 on 127 for right now. Yes, ma'am?
Are you going to be collecting this?
Eventually. So you just add it to what you already have.
Okay.
Just put it on that same paper. That way you don't have to start new ones. Yes, ma'am.
So with the domain and range, I just want us to point out which one's domain and which one's range.
All right. What's up?
Wait, okay, so for the other one, should we finish it?
No.
Okay. Just making sure.
Because what we'll do is, as we get into finishing about halfway through the linear stuff, I'll have a quiz for you guys prior to getting into the linear programming. So what we'll quiz on will be how do you find system of equations, how do you solve a system of equations, things like that. Some real quick graphing problems. Then go from there. We'll do that. Then tomorrow we'll start working on graphs. We'll work on graphing inequalities, graphing of absolute value, and we will talk about the constant of variation as well. Sorry. You can write it out if you want to write it. The technical way of writing out domain and range, if you guys want to get real fancy, domain is the domain is the set of x such that x equals blah 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 blah. I think that's how you write it out the fancy ways. Or you can just say domain blah blah blah, range blah blah blah. Do you repeat them? That's the only trick. If you have two x values, you don't write it down once. Okay? Two y values, you just write it down once. That's like the only real rule in those things. Okay. Evens 127, evens 251. Hey, that calculator finally opened. Seriously.